In this last chapter, our discussions will be entirely about developing a Spring Boot 2.2 cloud-native application, which can be deployed in various cloud containers. We will begin with Dockerizing our farm harvest management application together with its PostgreSQL instance. We will also be creating images and running instances in Spring Cloud Foundry, Microsoft Azure, and in Google Cloud Platform. Let us now start our first topic, which is deploying a Spring Boot 2.2 application together with its PostgreSQL instance to the Docker Cloud. Just like any other Jakarta EE8 applications, deploying Spring Boot 2.2 applications to the Docker Cloud is also CLI-driven and quite straightforward. In order to access all the data we used in the previous chapter, we need to create and run a separate Docker instance to channel all the access to the locally installed PostgreSQL. Let us now start our step-by-step process in Dockerizing our applications. Before we proceed, you have to properly install first Docker in your host server and then sign in to run the Docker daemon. You can optionally set up and configure the Kitematic dashboard to help you manage all of your Docker images. And then now our first goal is to create a new Docker instance to expose the locally installed PostgreSQL so that all the Dockerized applications will be able to access the database schema we used in the previous chapters. But before we run any Docker commands, we need to locate first the pghba configuration file of PostgreSQL, which can be found inside this data folder here. Yes, it's here. And then add the following line here inside the file so that PostgreSQL can accept any connections from the Dockerized host connections. Let us now create and run a Postgres Docker instance exposing our port 5432. We also need to mount the data folder of our PostgreSQL to the var live PostgreSQL data directory of our Postgres instance. But since I have mounted it already a while ago, I will be running this docker command just by accessing only the var live PostgreSQL data folder of the Postgres instance. So now let's run this command. Our PostgreSQL instance is now ready to access any Dockerized application connection. And based from our Kitematic dashboard, we can see that our PostgreSQL instance is now running. After the data source, we can now Dockerize our Spring Boot 2.2 applications. But first, we need our Spring Boot project to be deployed as an executable jar file. And then we also need to create a Dockerfile file in the project, which is needed in the creation of the Docker image for our application. This Docker file is placed in the main project directory and contains some Docker instructions to be executed during Dockerization. It always starts with the from statement or instruction, which tells Docker what instance to be used for the deployment. And in our case here, we will be utilizing a Linux-based instance which has a JDK12 runtime installed. And since I will be using a Reactor Netty server, I will be exposing my port 8088. And then I will be creating a working directory named app. And I will be copying the executable jar file of my project to this working directory. And we'll name the jar file section 17 jar file to make it short. And this entry point statement here will run my application during the deployment process. No need to discuss about the project components since we have already discussed how to implement Spring Boot 2.2 components, but I need to emphasize only one, and that is the database host server of our PostgreSQL data source. We will not be using any more localhost IP address since the PostgreSQL instance we will be accessing is the one that is deployed in the Docker container that uses the real IP address of our host server. If you don't know yet the IP address of your host server, we can just run the ipconfig Windows command here and look for the IPv4 IP address, which is in my case is this 192.168.1.3. And I will be replacing my localhost IP address with that one. Before I run any Docker commands, I need to build my project first to generate the executable jar file. After I run the build task, we need to open a command line terminal to run this Docker build command inside the main project folder. The name of my Docker image will be section 7.1, and this dot operator here means it will be accessing our Docker file, which is stored inside this main project folder. So now let's run this command. At this point, we have successfully created a Docker image for our farm harvest management prototype. Let us now verify if our Docker image is successfully stored in the Docker repository. So let's run this Docker images command. We did a good job since our newly created image is now stored in our repository here. Let us now deploy our project by running this docker run command, which will create an instance of our section 7.1 image. So let's now run this command here. So there you go. It's bootstrapping our application. We are now ready to access our application through a browser. Accessing now the list of profile records from our endpoint farm profile list using the port 8088 from our Docker instance will give us the following same data we used in the previous chapter. We have just presented to you all the details on how to deploy Spring Boot 2.2 applications, including a PostgreSQL instance, to the Docker Cloud container.